Bootstrap aggregations means simple bagging. So this is the first technique that in previous lecture we will see. In Ensemble's model, they are have they are have typically we are used mainly four types of techniques to ensembles the models, to ensemble the base models. So the first one is the bootstrap aggregations model. So the word bagging is coming from word bagging. So this B is responsible for bootstrap. This B is responsible for bootstrap. Bootstrap, and this this edging boost this edging is responsible for aggregation. Okay, and these bootstraps actually is statistical. These bootstraps actually coming from the statistical. This is actually statistical word. This bootstrap actually a statistical word. Statistical word. Okay, now let's see what is the actual intuitions of the meaning of bagging. Let's see it. Suppose let's take we have a data sets dn. Suppose let's take we have a data set, means train data set. We are talking about the training data set. Suppose let's take we have the data sets dn. The number of data sets in this data set, training data set, is n. Suppose let, means here we are talking about the training data set. Let's take, and the its points is look like this: xi, yi. And now first we have to do, we have to first sample the whole data set. And that suppose let's take, we are considering here, we are interested to consider here k models. So we have to sample this data set in k sampled, in can k sampled. So the thing is that the sampling is here, we are doing the sampling with replacement. Here we doing the sampling with replacement. Sampling, we have doing this sampling with replacement. Okay, first that we have to do. So first we have to sample the whole data. So this is the, let's take, this is the first sample, this is the second sample, third sample. In such a way we have doing this k sample. So suppose let's take, it's the sample 1, it's the sample 2, it is the sample 3, and let's take it is the sample. Okay, let's take. So in the sample, the point of the sample here will be less than equals to, in typically here the sample point is less than a, but if you just using theoretically, that point will be less than equals to n. So suppose let's take the first sample data set is equals to dn n1. Suppose let's take, and the number of points in these data sets will be, suppose let's take, is equals to, suppose let's take m. Okay, m number of data points. It's obvious that our m will be always less than is equals to n. It is obvious thing. So similarly here also, our second sample data set will be d2n. Here also it will be sample 4. It will be actually sample 4. Sample 4 sample k, it will be actually, if we just take the k sample, it will be sample k. kn, it will be kn, it will be kn. So now using this sample set, we have to make our models. So now we are using this sample set. We are, suppose let's take, we build a model, suppose let's take M1. Now using this sample set, we have used a model, built a model M2. Here similarly we have built a model M3. Here similarly we have built a model MK by simple using this data set, training data, as we have using this sample data now as a training data for edge model. Now by sample, this using sample data we have make these models. Now at that, what we have to do now, we have to in the last page we have to aggregate all these models and build our main actual model M. Suppose let's take our, after aggregations we have built the model M. Now from this aggregate from here as well from all the combined all. So now this step, so combining all the models, this step is called the aggregation step. This step is called the aggregation step. Okay, and this step is called the sample that this is actually our parent data set. Now from our parent data sets, by using the sampling with replacements, we have divided we have sampled our data sets through k sampled and through k samples. So this sample technique with sample with replacement, that is, so this sample technique is called the bootstrap sampling. This sampling is called the bootstrap sampling. I think you have understand now why this technique is called the bootstrap aggregations. Means first we have to sample our data set by using the bootstrap sampling, then by sample using this sampled data we have to build our model as a base model, and after that final state using edge models after aggregations. By simple edge model we have to aggregate and to build the final model. Because of these reasons, this technique is called the bootstrap aggregation technique. Now sample here, just if you just write this thing in language, so here mi, this models edge, I am now talking about HMI, edge base model. This is actually our base model. This is actually our base model, and this thing, this M is actual our what? This means actually our ensemble model. This is actual ensemble model. Okay, now if you just write this thing in languagely, if you just write this thing, AMI is built by using its sampled data. Its sampled data means DIN, using DIN means another language is a sampled data of size what? M, where our M is equals to less than n, or in technically it is less than equals to m, but typically it is less than n. Really we use less than n, but in technically if we write theoretically it will be less than equals to n. Okay, this means what? This means This means age model AMI here has seen a different subset of data. Okay, this simple means because we are sampled, randomly sampled here. Actually, we are just doing the randomly sampled with sampling with replacement. Means this sample are totally different, and age model that we build from the sample data that will taken here from different data set. Okay, so age model that is AMI. So age model AMI here has built from a different data set. From a different subset, different data subset of the actually the parent data. Parent, P-A-R-A-E-N. Okay, I am very weak in English. If I doing some mistake, please correct it. I think the parent spelling is P-A-R-E-N-T. I think R-E-E-T. P-R-E-N-T. Okay. So age models is now AMI has built from a different data subset from D, that is the parent data from. So the now just after building that step, what we have to do after building this step, we have to aggregate age model. Now this step is called the aggregation step. This step is called the aggregation step. In aggregation step, what are doing here? In aggregations, we have to do two kinds of job. There have two kinds of we have seen. So there have classification technique. There have classifications model, classifications, or there have a regression. If we doing the regressions, then we suppose first let's take we are doing the classification job. Our job is classifications. Then what we have to, how we'll aggregate this thing? So in classifications, we have already seen that KNN taken the majority vote. We have sample taken the majority vote. That we have already seen in KNN. And for regressions, regressions to build a regressions model, so we will take the mean or median. We'll take it. That thing already we have seen in the previous chapters. I mean decision tree, when we build the decision tree regressions, when we use the decision tree for regression purpose, then instead of taking the aggregations, we are taking the mean or median, and according to that we have calculated, instead of entropy we have calculated there the mean square error, and according to that we have building our decision tree. So the same things for aggregations, we are taken the aggregations operator as mean or median operator, and for classifications we have taken the aggregations operator as a majority vote. Okay, now let's see. Now let's take, and in runtime we have given a query point xq. Now let's take, in runtime we have given a query point xq. So now we are applying this xq for age model. Suppose let's take we have built how much model? A model we have built. So we have built M1 model, M2 model, M3 model. So let's take we have built K model. Now we will applying each query point for age models. We are applying first M1 model, then this we are applying this xq point for M2 model, we are applying this M3 model. Similarly, we are applying this x query point for K model. Okay, then we have taken its output. Then we've taken its output. Suppose let's take its output is suppose let's take we are doing the job classification. Suppose let's take its output is 1. Suppose let's take its output is 0. Suppose let's take its output is 0. So let's take its output is 1. Okay, let's take. Now in the final step we have to aggregate to build to take on the final decisions. To take on the final decisions, YQ. How we will take on? If we take on the if we take on the classification job, if we use the classification job, if we use this ensembles model for classification job, then we will simply consider the majority vote. So in such scenario it will be 1 or 0 according to the majority vote of the output for each model. It will be, or if we use this model as a regression problem, then we have simple using here the mean or median technique. So in such cases we will get some output as a real numbers. Phi hat, let's take regression. Okay, so that's actually we have to doing in runtime, and these things we have to do in this thing we have to do in the training time, and these things we have to do in training time, and this thing we have to do in runtime. Build an aggregation. So in classifications, that but one thing that I am mistake, in classifications this point will be 1, but in regressions this point will be some real number. Suppose let's take its YQ dash, YQ1. Suppose let's take its YQ2. Suppose let's take its YQ3. Let's take its YQK, and we have to take an all medians. Here for classifications we have to take in the majority vote, majority of all Y1s or zeros. Here we have to take a mean or median. YQIs. Okay, this thing we have to do in run, and these things we have to do in training time. Now let's take the bootstrap sampling. Now let's discuss the how this booster sampling we have to do. Just we have to do this sampling randomly from our data. Now let's see how this actually sampling we have to do. Let's now see the bootstrap sampling. Bootstrap, what is the spelling? Bootstrap sampling. Now let's see how this sampling we have to do. Suppose let's take we have taken a data set DN as a training data, and let's take the number of data points for this training data is, let's take the number of data point for this is 10k. Let's take for an example, number of data points from this training data is 10k. Let's take for an example training data. Okay, now first we have to training this model, but we have to using the first we have to sample this data. Suppose let's take we have building the k sampled model. Okay, k sampled model. First we have to sample this data, k sampled, first sample, second sample, third sample, up to k sample. So this is the first sample 1, sample 1. So this is for sample k, this is for sample k, sample k. Now what, this sample, using this sample, suppose let's take these samples is let's take the sample is dn1, suppose let's take the samples is, let's take dn2, n3, the sample is dnk. Let's take how this actually work. Now we will decide, we have taken here in the parent data, in parent training data we have taken 10k points. Now we have decided for each sampling we have taken the 5k data point. So the number of data points for the samples, now let's take it's 5k. We have one thing, this data we have taken here sampling with replacement. Here we have taken the sample, the sampling with replacement. Sampling and replacement means what? Means the data that will occur here may be chance there, that will be occur here, that will be occur here, that will be occur here. Because of we have taken here sampling with replacement, because of that for each data, for each sample data which contain that number of points 5k. So there may be a chance few data that have sample 1 that have already in sample 1, that may be a chance to be in sample 2. Okay, because of we have taken here sampling with replacement, because of these regions this data set may be overlapped, but the different, but these are the different, not equal, not actually equal, that are sampling here with replacement and randomly, and we have taken the random sample, and here we have taken the random sample. Okay, okay. So now in the third phase we have to, what we have to do in the third phase, we have to build the model by using this sample data. Suppose let's take by sample using this data. So let's take by using sample this data, we have built the model M1. By using this sample data we have built the M2 model. By using this sample data we have built M3 model. Similarly here also we build MK model. By sample we have trained this model. Build means here we have trained this model. Okay, now after at the final step, at third step we have doing this job. Now at final step we have to aggregate, and after aggregate we have to build a ensemble model, that is we call M. From here, from here, this step is called the aggregation step. Aggregate the model. We have to aggregate this and build this one. Okay, and after this these models, after building the aggregations, these models actually give our final result. These models are give us the final. Okay, these things we have to do in this. Now the problem, the advantage of this bootstrap sampling, so these things also we have discussed in this team, but now again the motto to again discussion is that variance, what is the actual advantage in this bootstrap sampling. Okay, now let's see it. So let's see this let's see, we have the in these models we have doing some variance models, means overfit model. For edge models we have making that already making is, suppose let's take it's the overfit model. Overfit model, overfit means what, in edge model there have some variances, and variances means what, Means if we change something in our training data, the whole models is changed. Means variances means if we small change in training data, then our whole models affects. Whole model effects that we'll see in the variance mode. That actually this is actually meaning of the overfit models. Now in bagging, what are the advantage in bagging? Let's see. So in bagging, the advantage of this bagging technique means bootstrap sampling. That's the advantage of this bagging technique. Now let's see. Bagging. Now in bagging technique, we will see the overfit, the variances. The age base model. That is a age base model is overfit model. By simply using this bootstrap sampling, the variances is reduced in bagging technique. Okay, we can easily reduce the variance in the final model, M. In the final model without impacting the whole data or whole bias, without impacting that. Now if you remember, in one of our previous lectures we have discussed the generalizations error, the generalized model. How it is actually, just revisit this concept. Generalized model means what? Generalized model means if our models give the response better for a future's unseen data, means the data that we have used in our training models that that are not used in the test data. Okay, means that's kind of thing. So the model that will give the better results in the future or unseen data. Okay, that's kind of seen are actually called the generalization model. If these models are better or for a generalization, for a future data or unseen data, that models is actually called a generalization model. And we have seen the generalizations error. We have find the generalizations error for a model like that. For a model generalization error, the generalizations error we have seen, it is a simple bias square plus variance is called the generalization error term. Okay, now here, now see this thing. Now how these generalizations error, this error model error are reduced for variances. Let's see. So here, what is the base model? So here base model is AMI is our base model. AMI is our base model. So here actually here our AMI is actually our base. Here actually our AMI is the base model. AMI is the base model, and in base model we have seen the variance is our bias is low, but we have taken our is model is overfit model. Is base model is overfit model means what? In these models we have low bias, but variance is high. But variance in these models are high. Because of that, we have called these models are overfit model. So for this base model, we have seen these models have low bias and high variance Okay, now if we apply the bagging technique, if we apply the bagging for this model, for if we taking the apply the bagging technique for these models, now what we actually think? Suppose let's take here we have 500 10k data, and in this 10k data we have changed the, suppose let's take in this 10k data we have changing the 100 data we have changed in the whole training data. Now, if we have not using this bootstrap sample, then in the train, if we change the 100 data, then this data will change also the final model. But here, not doing this kind of job. If we change the 100 data from the parent data, so this data, this 100 data, may be chance the fewer changes from this data, because we have taken here sampled data, because we have taken the sampled data from the whole parent data set. So if we change the only 100 data to our parent data set, so there may be a chance here may change some, suppose let's take here meet in between 100 data, here may chance to occur, suppose let's take here chance only 5 data, only 10 data here change, here only change, suppose let's take 5 data, here only change, suppose let's take here change only 5 suppose let's take here 20 data, so let's take here in the 100 data, here may change 15 data. So in each sample data, the whole changed 100 data is not affected. Some portions of the 100 data is changed from the each sample data. So because of the small changes, so for age-based models, the changes of the variances will be small because of that. So we will change only 100 data in our whole parent data. We only change in our training data set, only change only 100 data in our parent data, and we will see the very few number of points are changed in our sample data. Okay, because of that we have the low variance error here. In training data we have changing only fewer points, okay, that we change the large amount of the training data, but in sample data we have changed only few points, okay, that is that is only fewer points. Because of that our base models are not so affected by this. So if our base models are if in training period, if our base models are overfit model, but in the actually originally if we change some large amount of point in the parent data, but its effect is smaller, its effects will be impact smaller to our base models, so its effect will be smaller to our base model. In base model, if its effects is smaller, okay, if effects is smaller in our base model. Because of that, if our models is a overfit model, if our age based model is a overfit model, but because of this bootstrap, because of this bagging technique, we can easily reduce the variance, okay, because of that, okay, because here actually we have taken bias square and only variance term, so to find the generalization error for the main models, okay, just because of that, only because of these reasons we can easily reduce the the variance term. So just if you just summarize this thing, so what you will get here in bagging technique, what you will get in bagging technique, we have seen that we have bunch of In bagging, first what we have? First we have bunch of low bias and high variance models. Low variance models means what? This means we have overfit model, bunch of overfit model. Okay, in first step we will see. In the second step, in second is we have to combine. We will combine these models to make that. We combine means we will aggregate this model to make the final model. We will combine them by sample using the bagging technique. Bootstrap bagging, bootstrap aggregation, bootstrap for B, aggregation for AGG, because of bagging technique. And after using this bagging technique, we will see that we will build a low bias model, and also we will reduce the variance term. We'll see this thing. Okay. And the practically, when we learn the random forest technique, we will see this. We will apply this thing in the random forest. So we have seen just in previous chapter, we have seen if we increase the depth of the decision tree, if we increase the depth of the decision tree, then what? This means what? If we increase the depth of a decision tree, then we are making a overfit models, means high variance model. This means we are making a high variance and low bias model. This thing we have already seen in the previous chapter. Now by sample using here the boost, this bagging technique, we will build the random forest model. That is more better than the general decision tree model. If our general decision tree, if the general base decision tree is a high biased, but if we using sample this bagging technique to build a random forest, we will see this random forest final model is not so much overfit model, or is not so much high variance model. Okay, so and obviously these random forest models are most used and popular bagging algorithm. So till now that we have from all the bagging models that we will see, the random forest is the most popular and used in real world applications. This random forest, we will see this thing. Most used popular, and real world applications it has. We'll go to them, that we will see. Okay, now I think the bagging concept, how these things is actually better, how these things is done, the concept is clear from these lectures. Okay, just because of these techniques, because we have just sampled this thing randomly. Okay, sampled this thing randomly with replacement. If we change if our parent data changed, then this effect will less impacted to our sampled data, because only of this thing our bootstrap sampling, means bagging technique, is so popular to build a ensemble models. Okay, now let's see how to build this as bagging technique to build a ensemble model, that we'll see in next lecture.